Good evening, everybody, and welcome back to another episode. Continuing with the plasma engine. Uh, I've been doing some research. Um, there was a lot of things I forgot that I forgot with regards to lasers and things of that nature. Um, so basically, what I found out is uh, my initial concept, I'm too focused on how it was done previously. When I don't need this fancy looking tail. I just don't, because I don't have to focus or reflect and refocus in order to get ignition. All I have to do is wherever the laser is coming in, I have the focal point. Let me put this somewhere in this area, which is going to require these to be moved, my laser heads. And I'm thinking of actually putting them out, over here because I want as much buffer between where the air is intaking and then compressing to increase the flow so that my focal point is like basically right in the middle of the pipe. And if I utilize a powerful enough laser system, then goal would be to get a continuous ignition and just like you would see in a jet engine, only much, much hotter. So with that said, I think what I'm going to do a little slight modifications here. And let me, what do I got here? Okay, let's go ahead and back this up. I won't need this dome. And we're going to go ahead and modify this bad boy. I mean, it looks cool, but it's just not necessary. So let's take out this piece here. Yep, that piece there, and we'll go ahead and remove that. Don't need that. And I'm considering just mirroring this down or just maybe doing something a little bit different. Let's see, where is the center point of that? Right there. We'll just do that. We'll just make it a bullet. Make it equal. And this will connect to that. Well, maybe. Why? Oh. Honestly, I can get rid of that. Put that there. And guess we'll make that. Okay, what is going on here? Oh, because okay, all right. Whoops. Get a dimension on this. Just make that easy. Go ahead and trim out what we don't need. And then accept that. And it looks like a pill. So, oh, what is this going on? Bubbers, why every time? This big boy keeps coming and he's not happy. Come on, go on. Every time, bud. Every time. All right, let's look and see what this is doing. Honestly, I could extend this to, let's see what this, oh, for Pete's sake. Give me what I want. let's extend that down. And that'll increase the surface area. Also changes the angle a little bit. And it still looks fine. So what I'm thinking here, honestly, this almost needs to be component parts to a fan system. All right. Ah, my my cord got wrapped around my chair to the headset, and I about yanked my head off my shoulders. Oh, goodness. All right. Let's go ahead and save that. Make sure it doesn't conflict with the assembly. It does not. What we got there? That is odd looking. Why is that doing that? Is it because of the cutting plane? Yeah, okay. So it's not anything incongruent. Okay, so that's fine. And I definitely want to move those holes down. So let's look at this. So honestly, I can get rid of these things. And I think I'm going to just delete the circular pattern. I don't know why it did that. That's really strange. Yeah, we're just going to, whoops, not that. We're just going to remove that. As much problems as I had doing that, just get rid of it. Let's see. I was also doing some research on materials, and one of the things I found pretty interesting, what was it called? Tungsten actually has the highest melting point of all the metals, but I don't know if it would if I would need something that crazy. But it was a good thing to see. It was an interesting read when I was doing material research. Right now, I'm just leaving it titanium because I don't even see tungsten in the list, and I don't even know. I mean, tungsten is generally reserved for like welders and stuff like that. Also, I believe they're also utilized in nuclear power plants uh, for housing the rods of uranium because of the low chemical reactants that it has when it's in well, when it's dipped in the water. At least I could be remembering the information wrong, but that's what I recall. Let's see. So, well, with that said, I can keep on going. Let's go with the right plane, put a sketch on there. Now, I found out really interesting by doing some research on lasers and stuff like that. I used to have a book called the Laser Cookbook, and I can't find it. I looked for it earlier today, and I couldn't find it, so I don't know where it went. But actually, let me finish this because I want to see what I can do here. Let's go 2.5-inch diameter hole. And I'm gonna put that, well, I don't like doing, because that's in the middle of that curve. I don't want to dimension to that because that's just bad practice. And let's do 16 inches for now. And we'll make it in line with the center, put it along its center line. And feature extruded cuts. Just go through all. Yeah, that's fine. And then I'll rotate that around. Let's see, show. Maybe I can grab that. And that feature. Oh, that's not what I meant to do. I do not want to rib. That was cool though. Come on, what's it doing here? I don't know why that's weird. I don't know what that hand is for. I've actually never seen that before. This one. Oh my goodness, come on. Circular pattern. Since I made those holes a little bit bigger, I think I'm going to go with 5. Just for now, just so there's plenty of material there. And then I'm thinking I need this to be a little bit longer. Let's see. Now, do I want to increase or shrink down that? No, I'm not going to worry about it right now. All right, let me see what we got here. That's my front plane. If I do my right plane, well, that's a little funky. Okay. Does any one of those give me a dead's eye view of it? Guess not. Okay, so it doesn't matter. All right, so anyway, what I was, hopefully I can explain this. What I was reading about with lasers is that there's a formula for figuring out the frequency that's available within, there's a variable frequency that exists depending on what they call, I believe it's called the chamber length of your lasing medium. And really what that means is if you have, this big of a diameter of a rod and it's this long, your wavelength pattern that's usable energy output is going to be different than if it was something this short. With that said, depending on how much energy you input into, there's a certain percentage of that is usable power coming out of the laser. Different materials, whether it be a solid, gas, or liquid, provide different responses as far as energy output. I'm not going to go into a huge explanation of it because I'm grasping it, and I'm sure I would say a lot of things that are wrong because I'm still getting everything back in my head about how all that works. So with that said, I can actually utilize this space in here that holds a lens that actually gives me the focal point to the center of this area, or I could even do it up in this area. However I want. It really doesn't matter. So that part is going to come along once I identify the type of laser that I can use with this and what other equipment I would need to drive that laser. Um, there's a lot of these guys on YouTube that are building some pretty crazy stuff with lasers. And they're getting like tattoo removals and amping those up. So it's really fascinating. And it makes me feel uh, kind of like this isn't something that's going to have, $1 million to get going. I mean, once I get into a position where I can actually start doing some experimental type stuff, I could get some junk lasers and do, small iterations of this thing on a scaled down version to do just some testing to see if even the concept is reasonable. So just something that was really cool, and I was glad I actually started looking into that. Okay, so what I'm going to do here, oh, I don't want to start a sketch. I want to do a hole. What I'm wanting to do is to create a fastening plane for the turbine, the rotor. And that's going to be a threaded screw. I want it, hello, okay. And I believe quarter 28. Oh, that's pretty tiny. I can actually bump that up. Let's go a half inch 20. And I think I'll do something like that. So these are going to be there. And those are going to be horizontal, horizontal. And oh, I also need oh, need a center line, and I think I'll pick an arbitrary point. But why is it doing? Oh, there we go. Let's see. How do I want to do that? Oh, here to here, that'll be coincident. There we go. Now it's locked in place. Then I want to circle to the midpoint of that. Which I'm gonna have to move this bad boy out of the way so I can grab that. There we go. And then that turns into my center line, and that goes there. That gets on there. I guess I could have done one and then did a rotary, but that's all right. I'll do it this way. Making it symmetric. Boom. There. Now I just got to make sure that doesn't go all the way through. That's fine. All right. That will secure that. And then let's see for this. I think I want to do almost need to destroy this and make it a couple, actually make it its own assembly, but not exactly sure how I want to do that just yet. I could, because honestly, this thing could be, instead of being driven by something, it could be powered. I think I'm just going to bake it for now. Until I can come up with a conceivable design or see if I can find something that's out there that'll work anyway as well. And I gotta double check my design here on the fence because I don't know. That's more of if I'm pushing air in from an outside source rather than spinning this to create the wind. Because fan blades, they're a little bit different. They have a little bit of like a propeller type design to them rather than this turbine, which is good for water and air. But I guess jet engines are pretty much like this, kind of. Eh, it's more like a boat propeller. I'll have to look at that and see if there's something that I'll have to change or download something. In fact, yeah, I think I'll just leave it. But I am wanting mounting plates. So let's see, where is my top plane here? Right there. Let's look at this. Look at this in the assembly here. Hmm. what's comes up about, whoops, see if I can get a height on that. I don't know if I can. No, it won't let me do that. All right, so if I look at this, wait, is this one? Nope. Okay, that's weird. I'm used to playing games where I don't see my bottom bar. There was. Where's it? Well, from here to here, 2.9. Let's look at that, see what that is. I forgot what the dimension was there. 2 inches, okay. 4-inch diameter, that means a 2-inch radius. So let's open up a new part. And then I think what I'm going to do I'll plan on this. I'm going to sketch some guidelines here just so I can, oh my Lord, what is this doing? And I want that, oh, that's on the dimension. I need that to be for construction as well. And I need the diameter of that circle. I guess I gotta get in the sketch for that. 5.5 inches, okay. 5.5 inches in diameter. So, let me put a point here, and a point here. And we'll do a center line vertical. I apologize for that. I still have not figured out why it does that. Make symmetric. And that's going to be 5.5. All right, so what I'm thinking here is I'm going to do a disc. All right, a disc with a huge arc. Somewhere in there. And then connects to there. This, and this is going to be symmetric, and that's a 1/2 inch. What was the thickness of this? I think that was an inch. Oh, really? That's dumb. Seriously? Yeah, 1 inch. inch is the thickness there. Okay. So from here, I need ½ inch on either side. Okay, that's fine. I can do that. We'll do, yeah, we'll go ahead and do a ½ inch. And then I want this to come to here. And there. Oh, Lord. Oops, I should have continued it on. Okay. There's that. And then that's going to be 1 inch. This is going to be, should be symmetric on that. Oh, but that is way taller than I wanted. Okay, let's try this again. Let's get rid of that. Can I go? I should only need half of this. That's better. That's more along the lines of what I was thinking. Now I can bring that up. And I think what I'll do, whoops, what I'll do, can I do that? No. Actually I can, then I change that to, been a while, leaders, first star condition, I want minimum? Yes, right there. And then let's make that 0.5 and see what that looks like. All right, I'm gonna spin that around. Only need 180 since I did both sides. Oh, wait, what? What in the world? Okay, that was... All right, what does that do? Sketch is open or self-intersecting. Or it didn't, oh, because of that, okay. Okay, let's just... So stupid. Now let's all right. There's that. Now, um, slice into that. And I want let's see. I want to be able. Can I grab that? No, it won't let me do that. Okay, that's fine. That's fine. Let's do vertical infinite length. Oh, whoops. Circle. Yeah, okay, that's not gonna work. Oh, you know what? I think I can do this and then grab. Can I grab that edge? Used to be able to do that. Oh, maybe this? Oh, Jesus. Maybe? Used to be able to do it that way. It used to be not as. Oh, it only grabbed that. Well, that's kind of dumb. I have this vision in my head. I'm just trying to translate it into how I need it to do on here. Let's try this. Let's go with okay. Why I want that to. It's not behaving itself. Maybe I need to come at it from a different approach here. So I think my brain is just not cooperating with me here. Let's go with the top and let's do, you know what, let's just, air inlet prop, well, why not? I need about 90% of this stuff removed, but I need a through hole at the top, countersunk. So I think that'll be the first thing I do. Wizard. I want a clearance hole. Oops. Hole. Clearance hole for ½ inch. Yep. Position. I want that right there. Boom. Did it get it? It did. Okay. Okay. I gotta put it on the surface and then tell it to pierce through. Okay. What? What is it doing here? On why? There we go. There we go. That's what I want. Okay. And I want that, yeah, that's fine. Oh, I think I want a counter bore though. Let's try it that way. No. Okay. Socket head. Oh, let's try that. ½ inch. ½ inch. And ½ inch. I don't want it to come up. I actually want it to be a little lower. Fit normal, yeah. Options, head clearance. Maybe that's what I want. No. Wait. Yeah. Oh, yeah. Let's do 0.05 because I think that's all we're gonna need. All right, there's that. Ooh, that's thick. All right, I may have to change the thickness of this bad boy. Now, let's get the orientation. Now, all I want is little slivers. So, what I'm gonna do is project these out. Let's see, top plane. And let's do this. That just seems so huge. There's no way that's right. What is that? Because that just don't look right. That looks way too huge. Evaluate, of course. It's 1 inch. I have a hard time believing that I made that thing, whoops, an inch. That just Does not look the same. Could be, but it is 1 inch. Okay. It looks really strange. Wait a minute. Something ain't right. That's the diameter of this? Did I really only make that small? Okay, something ain't right here. I did something. I didn't do something right here. Let me verify something because it just doesn't look quite right in the head. That's 11 inches. So it gave me a read. Okay, that's what I'm missing. Ha. Okay, that looks a little more like it that I was actually going for. Okay, there we go. Okay, now it makes sense. All right, let's try this again. Top plane. I want to use this as my guide. So I'm gonna do, let's do it. Whoops, come on. 2-inch circle in here. And then I'm gonna do, whoops, let's try this again. 1-inch circles here. Oops. No. Double check again. Oh, for Pete's sake. 4-inch total. Okay. Good night, Nelly. I'll get it. I'll figure it out. 4. There we go. Now we're gonna do. Right now I'm just doing this to see how it looks here. Tangent. Tangent. And then I'm gonna bring this way out here. It's what? 15 maybe? Then I'm gonna do the same thing on the other side. Okay, I think I'm enjoying that. Now I need to do kind of do this in reverse. All right, now I need that copied 8 times. So I need this, this, this. Circular pattern, 8. And then I got to cut all that out and then extrude cut the opposite. Oh, I don't like that. That's not going to do what I want it to. Four's good. But it doesn't give me that. Okay, let's get out of that. I think I need to, let's make this 3. And let's make that bigger. No, I want it smaller, sorry. 14 maybe? I need that dramatic effect. Okay. Now let's see what that looks like. I'm gonna have to put a little curve in there, I think, because that looks a little bit weird. Still not giving me what I want there. Trying to be too fancy with it, I think. What is this shit? Oh, that was something else I need to look at. Okay, this just isn't working the way I wanted it to. Can't do these because it's just not doing exactly what I want. Bidirectional. Whoops, bidirectional. Let's do 2, 5. Bring those down here. No, I need that to be. Come on. There we go. Bring that around. Let's see. Can I massage that a little bit? Huh? Oh, okay. Yeah, I got you. I'm sorry. There we go. Now, this. Oh, I don't need that. There we go. And I'll go ahead and make it the 8. That's going to be overkill, but to save time, I'm okay with it. Seriously. Oh, that's what it needed. Okay. Cut all those out. And then I have my spiders. And then let's see if I can do this the right way. Sometimes doing this is tricky. I want to cut, but I want to flip the side to cut so it cuts everything but what I just selected. And we want it through all. Going the opposite way. There we go. All right. So good so far. And I think that's what I want. Yeah. That's what I was going for. And edges are a little bit funky, but that's okay. What did I use here? Did I use half inch? Yeah. Oh, no. That needs to be, want those half 20. Oh. Okay. That's fine. Half 20, half 20. Okay. Yeah, that's fine. Stop. Go away. All right. And then, all right. So now what I need to do is do a slightly, let's go. That counter bore is going to be for the same thing here. So let's, I want it to be oh, okay. There's a way to do this. I need that to be flipped. There we go. And no, I want it to be nope, shit. Counter bore. Oh, what? Oh, not binding head. We'll do a I don't want to do a sock because that'll make it really tall. Hex bolt. And no. Shit. Okay, that's not gonna work. Okay, gotta do this differently then. Need a plane. That's just slightly above that one. Let's go with 0.375 on that and see. Actually, that looks too much. That might work. All right. That way I can make sure I'm on the right plane here. Okay, so um, go with that. What? No, I want a half inch. Mm, that's fine. I want it on that plane. Oh, why is that so huge? That should not be that. Oh, should not be that big. Why is that so? That means these aren't big enough. Okay, then that's that's just freaking huge. Um, yeah, that's not even thick enough for the head clearance. May have to reconsider that size. I think I'm gonna have to drop down to a quarter, and I'll do that on the other as well. Uh, that gives me enough thickness there. Through all. Is that right? But I'm gonna have to have it come up some. All right, that's fine with there. Let me bring this up. Oh, pretty close. Let's do another little adjustment on that. What did I have? Did I do 0.25 was too little. Oh, I've got to have it come, okay. That's still not, oh, okay, I see what's going on. What? All right, where is that out? Why is that? Oh, it's not locked in place. Can I, is that where it needs to be? I don't believe that. Let's make sure here. It should be. Ah, come on. 11. That's pretty damn close to where it's supposed to be here. There we go. What? Why isn't it? Oh, for real? Good Lord. There we go. All right, there's that. Now, what is the depth on that? 0.13. So I need that. does it keep doing that? Point 375 seems, but I'm only seated right there. I need that to go down, so I need more clearance. That's what we got. Okay. Let's go. What in the hell is going on with this thing? Uh, First, no, no. Head clearance. Ah, there we go. That's what I want. And I think I'll give it just a little more. There we go. There we go. That's what I want. Okay. That part is good. Okay. Now I should be able to make. Oh, hey. Looks like a disc brake or a donut with very well placed sprinkle. Oh, you guys are silly. To me, it looks like a cover to an old Honda Civic, a hubcap cover. Not that piece. Before I start cutting on it. This one? Yeah, before I started making the. Okay. Yeah, he's fine. And that is really thick. That is really thick. Okay. You mean before I did this? With very well placed sprinkles. I don't know. Alright, let's get this arrayed. Circular pattern. We're going to do 8 of them. And will it give me that? Yes, it will. Alright, cool. That's fine there. This took a little longer than I wanted. It's not exactly what I'm looking for, but it's close enough for what we're doing here. Alright, now I need to change these to quarter 20. Why does that look so much? Oh my goodness. It's fine. Alright. Do I have that saved? Save that. And I can probably even make those even thinner. I should, because I really need that airflow through there. And my goal is that this becomes a component piece. Uh, oh, whoops. That. That's what I want. Okay. We'll do this. And that should mate to this surface there. Blonk. Oh, well, that's a little interesting. I have something going on here that needs to be much more bowed up. What in the world happened here? I I spent all this time on it and I don't like it. I mean, it kind of gets the point across what I was going for, but it just looks too, I don't know. I just, I don't know. I mean, it looks all right, I guess. It just needs to be more pronounced. From there to there, I thought that was only 2 inches. I need to double check something here. Ah, it's 2 inches in diameter. That's why. That's fine. Continue to ignore the error, and I will figure it out in a second here. Let's get rid of the circular pattern. Let's find out what's wrong with this. There should not be anything wrong with that. Oh, okay. This thing is all screwed up. Why did it go there? That's kind of dumb. Okay. All right, now I gotta get that fixed. Oh, Jesus. Um, this. Why is it keep doing that? Jeez, crow. I need this plane. Goodness. Five. Definitely needs to be 0.75. And then I'll have to bump that down again. Oh my god. 0.2. No. No. Fuck's sake. I'll just have them rip that out. Okay, it's fine. Spider, spider. Metal spider. Oh, wrong one. There we go. Now that's what it's supposed to be. I still don't like it. I think it looks like shit. I think these need to be thinner. But that don't look too bad. It's work in progress. All right, now let's see. I think now is a good time for a leg stretch because I know I want the lasers to go. This is the laser inlets, and I need to look at how I'm going to do my magnets on here for the magnetic confining of the plasma stream. And then I gotta know what to do on the out outset. All right, I will be right back in a few minutes. Gonna go do a leg stretch, refill the water bottle, and all that good stuff. Sorry, I clicked the wrong button. I'm back. All right. Now for a little bit of concepts. Now, in the first episode, I told you that this was based off of the Hunt for Red October, the movie. The concept, well, the overall concept, as far as the hydrodynamics are involved, and when they built the Yamato, I believe, they had to have like these massive superconducting magnets, which basically increases the for lack of a better word, power um, that they output, and those are measured in Gauss, Gauss. Um, and this is something that, oh, thank you, love. I forgot my water. Let's see. Magnets used in magnetic fluid based. This is nothing that I want. Um, let's see. I don't want to use electromagnet. I mean, I could use electromagnets, but that would require more power up front. So I'm thinking just natural magnets like neodymium. Is that what they're called? Yeah, neodymium magnets. Those are expensive though, from my understanding. And also, let's see, hydrodynamic, um, magnetohydrodynamic generator. Okay, so yeah, this is what I'm looking at. I don't want the, I'm not really looking for the Hall effect. Uh, oh, really? That's as big as it gets? Okay. Accelerated nozzle, segmented electrodes. And those are, look like they're embedded. And then they use solenoids, which are basically electromagnets. They really have a really good pincher for that. It's hard to know because they don't have a lot of information because they just, it's like they the research on it is very sketch. I mean, if you look through the history of it, it's kind of crazy. First stage of a gas-cooled nuclear reactor. Yeah, I know. That's what I've been saying for 20 years. Let's see, material and design uses. See, and I told you that they, coal burning. Let's see. Advanced coal-fired, yeah. I just don't understand why they want to use coal. I mean, I guess the energy output per unit is pretty high, but they still have to seed it to make it more uh, electrically conductive. So I don't know. I think there's other ways to do it. Can I get Magneto and images perhaps? See if there's some better. See, this is kind of what I've been envisioning for a while. And this wasn't around when I just want to look. Oh, wait, that's huge. I can't do that. Stop it. Nope. Magnetic separation of charges. Magnetic field is going that way. So my initial thought, wish I had a washer. Well, this will do. Was to have, like, say my finger's the nozzle and the magnets are like this, segmented all along the pipe. But that means that the north and south are in line with the direction of flow. And what they're saying is basically I have to have a north, like this side is north and this side is south. So I'd have to do them like this, which bar magnet would be better, but it would have to be I hmm, motion of conductor, magnetic field. Basic principle. This working fluid. Anode wall, cathode wall, insulating wall. That is a little bit different. See, they have so much conflicting information because, like, for instance, for this, north, south, so they're saying this whole length is the south, this whole length is the north. Magnetic field lines. Yeah, that's look. It's like they're putting in monopoles, and that's just dumb. Let's look at images here on my. So, if we go by this, this is actually a little bit velocity of plasma. So electrons will collect in one. So we're connecting the magnetic field through. Oh, why do they gotta make these things so small? So annoying. I actually watched a video where a guy did a little boat. See, yeah, this is more like they supply power to the electrodes. See, they don't have the magnetic field in here, which that would create a magnetic field. So it pushes the water through. Oh, wait, here we go. Yeah, this is pretty close to what I had in mind. But this is for a space propulsion. See, that's why I think the magnetic coils that I was envisioning. But see, then you have north and south. I guess if you have north and south, I don't know why that wouldn't work. Let's see, what's this? That's not what I want. Now we're getting into stuff that I don't want. Image control turbo engine, alternate power and plexus. Oh, that's interesting. This is exactly what I proposed a while back ago. Huh. MHD generator. Okay, come on. I need some pictures. Not very. Let's see. Sorry guys, I really thought I could see they used a saddle magnet, air capture inlet, reionization, saddle magnets, huh? See, I saw those too. And if the north, so, okay, I guess this is what I'm wondering. As long as you have a north-south, this is frustrating because it's not clear, or it's just a part of physics that I never learned. Because this is too simplistic of a, does not make sense to me. You're putting north and south. Okay, magnetic field lines. I need to look at those again. I'm sorry, guys. Confinement. Law. Here we go. That's what I'm looking for. Now, a saddle magnet, though, that's what I need to look at. And why is that different? Why? Because I've seen that many times. Okay, here we go. Yeah, this is where it gets to the point where I don't understand this part of it. I think I'm going to have to do some more research before I make a final decision on that. And I apologize that I wasn't a little more prepared for this part of it. There's so many ways to do this. I don't know which is the right way. See, this looks kind of like what I was thinking, but what are my lines? Which end is north, which end is south? It doesn't tell me. And these will be done with, again, why, wow, why am I choking? I'm gonna have to do some research on this because to me, it's so conflicting and confusing. So I think, yeah, I only got one other part and did a few modifications, so I feel really bad. It's dumb. This may be, this is a different beast altogether. So far out of my league, but we'll see how it goes. All right, I think I'm gonna cut that, make that it for tonight, and I'll try and iron out the magnetic issue, figure out what the hell I need to do, because it's just there's so much conflicting information between the right hand rule, field lines, and how they interact with ionized or plasma gas. Not plasma gas, plasma is its own separate form of matter. So that'll be it for tonight. I will be back next week at the same time, same place. So hope everybody has a great week, and hopefully I'll be more prepared next week. Thank you for tuning in. I'll check y'all later.